नमस्कार विद्यार्थी मित्रांनो, सध्या आपण बघत आहोत रिफ्लेक्शन ऑफ ट्रान्सव्हर्स वेव्ज अँड लॉन्जिट्युडनल वेव्ज. मागच्या वेळेस आपण रिफ्लेक्शन ऑफ ट्रान्सव्हर्स वेव्जचा अभ्यास केला. तो 1-2 मिनिटात मी रिव्हिजन त्याचं घेतो आणि लगेच आपण रिफ्लेक्शन ऑफ लॉन्जिट्युडनल वेव्ज म्हणजे साऊंड वेव्जकडे आपण जाऊया. रिफ्लेक्शन ऑफ ट्रान्सव्हर्स वेव्जमध्ये आपण पहिल्यांदा डेन्सर मीडियमवरून कसं रिफ्लेक्शन होतं हे पाहिलं. समजा अशा प्रकारे ही आहे डेन्सर मीडियम आणि या वेन ट्रान्सव्हर्स वेव्ह इज इन्सिडेंट, क्रेस्ट ऑफ ट्रान्सव्हर्स वेव्ह इज इन्सिडेंट ऑन दिस denser medium, then wave velocity is reflected, particle velocity is also reflected because particles of that denser medium are not free to vibrate. Phase change of pi radian takes place and therefore crest is reflected as trough and trough is reflected as crest. This is the reflection of transverse wave from denser medium. Similarly, second point, when reflection of this transverse wave from rarer medium. Let us suppose that this is that boundary of the rarer medium and a transverse crest of transverse wave is incident on this rarer medium. Wave velocity is reflected. Particle velocity is not reflected because particles of the denser medium are not free to vibrate. So therefore there is no any phase change takes place, no phase change takes place, and therefore crest is reflected as crest and trough is reflected as trough. So this diagram and this explanation is necessary for this reflection of transverse wave. Now let us see similarly how the reflection of longitudinal waves takes place. Before going to that topic of that reflection of longitudinal waves from rarer medium and denser medium, first of all let us see how the longitudinal wave consists of. Longitudinal wave is divided into alternately compressions, this is compression, and rarefaction. Again compression, then rarefaction, compression, rarefaction. So in this way alternately compressions and rarefactions are there in the medium of longitudinal waves, that is sound waves. During compression all the particles are gathered, they are collected at a place. So at compression how the wave velocity, so first of all wave velocity is directed towards right side, but particle velocity at that time, suppose that at compression particle velocity is in the same direction as that of wave velocity. So if both the directions are same, then we call that region as compression. Means when wave velocity and particle velocity are in the same direction, let us consider it as a compression. Now suppose wave velocity is in the right positive direction of x-axis, suppose, and in the region of rarefaction all the particles are moving away from each other. So let us suppose that particle velocity is in the left direction for rarefaction. So in short, when wave velocity and particle velocity are in opposite direction, then let us suppose that it is a rarefaction. So remember this thing, when both wave velocity and particle velocity are in same direction, then it is considered as compression. When wave velocity and particle velocity are in opposite direction, then it is considered as a rarefaction. So this thing is important for the study of reflection of this longitudinal wave, that is the sound wave from denser medium and for rarer medium. Now let us start for the explanation of reflection of this longitudinal wave from denser medium. Suppose that this is the boundary of that medium, that is the denser medium, and a crest of compression of this transverse wave is incident on this denser medium. This is suppose compression. Now here wave velocity and particle velocity both are in same direction because there is a compression. What happens to this wave velocity? Wave velocity is reflected whenever there is a change in medium. Wave velocity is reflected. What happens to this particle velocity? As the particles of this denser medium are not free to vibrate, particle velocity is also reflected. So wave velocity, particle velocity both gets reflected, and hence we say that compression is reflected as compression because both are in same direction and there is a phase change of pi radian takes place. Similarly, when this longitudinal wave is reflected from rarer medium, then let us see what happens. Suppose the compression of this longitudinal wave is incident on rarer medium, then wave velocity and particle velocity both are in same direction. Wave velocity is reflected because there is a change in medium, but particle velocity is not reflected as the particles of this rarer medium are free to vibrate. So therefore compression is reflected as rarefaction here. Compression is reflected as rarefaction and rarefaction is reflected as compression. So remember these things, and here there is no phase change because particle velocity is not reflected. So which points you have to remember? Whether wave velocity is reflected or not, particle velocity is reflected or not, phase change takes place or not, compression changes to rarefaction or rarefaction changes to compression, what happens exactly. So in this way you have to study this reflection. So here are the notes of this reflection of longitudinal wave from the denser medium and from the rarer medium. See here, reflection of longitudinal waves from denser medium and from rarer medium. Here if you see carefully, then those 2 points are explained initially. The wave velocity is always reflected whenever there is a change in medium. The particle velocity is reflected only when particles of the medium are not free to vibrate. So this explanation already we have studied in the previous question. If particle velocity is reflected, then a phase change of pi radian takes place, and if it is not reflected, then there is no change in phase. And one more thing, for compression, wave velocity and particle velocity are in same direction, and for rarefaction, particle velocity and wave velocity are in opposite direction, that which we have just considered. Then after that, how the reflection takes place from denser medium. When compression of longitudinal wave is incident on denser medium, then wave velocity is reflected, particle velocity is also reflected, phase change of pi radian takes place. Then compression is reflected as compression and rarefaction is reflected as rarefaction. Then second thing, reflection of longitudinal wave from rarer medium. Here what happens, compression of longitudinal wave is incident on rarer medium, then wave velocity is reflected but particle velocity is not reflected, and therefore there is no phase change takes place. So compression is reflected as if compression is incident, then the rarefaction is reflected and vice versa. The diagram of this reflection of longitudinal wave from rarer medium is not here, so you have to draw that diagram in this way. First of all, you have to draw such a boundary of the rarer medium. Here this is a rarer medium, and compression is incident in this way. Compression of that longitudinal wave is incident. Wave velocity and particle velocity both are in same direction because there is a compression. Wave velocity is reflected but particle velocity is not reflected, it remains in the same direction. As wave velocity and particle velocity are in opposite direction, then it gets reflected as rarefaction. So this is the diagram, and there is no phase change takes place. So this is the diagram of reflection of longitudinal wave from rarer medium. So notes already I have given in PDF file. So see those notes, and after that we will see this principle of superposition of waves. Okay, thank you all of you.